is another good problem then. It gives us a real root, so we know one of the factors is x minus 3. We can divide that into this polynomial to get what's left over, and then use the quadratic formula to find the complex roots. So I'll use synthetic division. You put k here, or you put the 0 here. That's what k is. And then you put the coefficients here. And you drop down the 4 and multiply. 12. Add. Multiply. Just give you 9. Multiply. If you positive 27, you get no remainder. That's a good sign. So what's left over is this polynomial 4x squared minus 4x plus 9. Okay, there's two other zeros that come from that. They're complex, and in order to find them, then I'm going to have to use the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. All right, this simplifies to a negative 128. Obviously, I can take out the negative sign and make that I. I just need to simplify the square root of 128 now. Guessing it simplifies, so let's try to find a perfect square that comes out of it. 64 times 2 we can make it. That's the biggest perfect square. And then it'd be 4 plus or minus I. The square root of 64 is 8, so it'd be 8I square root of 2 over 8. Now 4 goes into 4 once, it goes into 8 twice, it goes into 8 twice. So it'd be 1 plus or minus 2I square root of 2 all over 2. There's my two answers. I'm going to have to enter them in like this. 1/2 plus I square root of 2 and 1/2 minus I square root of 2 if you divide 2 into both. There's my two answers. Okay, next problem I'm going to write in here and passes through this point. So x plus the square root of 11. And then also I have x minus this complex number, negative 2 plus, and its conjugate as well has to go in there because of our conjugate theorem. So the x minus negative 2 minus 9i. All right, this would be x squared, middle terms are going to cancel, plus 11. I'm going to FOIL these two out separately real quick. This would be x squared minus x times negative 2 minus 9i. Minus x times negative 2 plus 9i. Last times last gives you positive negative 2 plus 9i times negative 2 minus 9i. All right, let's simplify. So it'll be x squared plus 2x plus 9xi plus plus 2x minus 9xi plus 4, middle terms cancel, be minus 81i squared. I can simplify this then some more. This cancels with this, so I have x squared plus 4x. This is a negative 1, so it'll be 81 plus 4, which is 85. All right, now I still have to multiply that by this right here. This x squared plus 11 is still a factor. And I'm going to go ahead and distribute. Again, FOIL. X to the 4th plus 4x cubed plus 85x squared. I like to kind of write, sometimes I like to, with the second one, I'll do right below, keep it in order so I can add easier. So 11 times x squared is 11x squared. 11 times 4x is 44x. 11 times 85 is 935. So then I can add, I end up getting x to the 4th plus 4x cubed plus 85x squared. I'm sorry, 85 plus 11 is 96x squared plus 44x plus 935. Now I'm almost done. This is my polynomial. The only thing is I gotta make sure that it goes through, I know that it goes through the zeros now, the roots that we have, but I've gotta make sure it goes through the .0150 as well. In order to do that, we can just change the vertical stretch of it. So we can multiply this whole thing by A in order to make sure that it goes through that point. So to do that, I'm gonna put an A here, and I'm gonna plug in the point that they gave me, which was 0,150. So if I plug in 0 for x and 150 for y, I get 935. So divide both sides by 935, and your A value is, and I just realized I made a mistake. This is going to happen a lot, so get used to it, and it's okay, we'll get through it. But when I multiply this should have been a minus 11 right here, which makes this a minus 11, which changes this. You know, this would have been, let's see, negative 11 times x squared gives you negative 11x squared. Negative 11 times 4, so these would be negative. So that would be negative. This would be negative. And this would be 85 minus 11, which is 74. All right, so let's try this again. When I plug in 0 for x, I get negative 935. So my A becomes 150 over negative 935, which is negative 30 over 187. I'll just leave it as a fraction. So I'm going to put that right here and see what Webwork needs for their answer real quick. All right, yeah, so you might not like this, but it's going to be a lot of work, and you're going to have to take your time, be focused, and not make any mistakes, because you're going to have to FOIL. I think you're going to have to multiply this out. I don't know if Webwork will accept this answer the way it is right here. It might. Actually, I'll try that real quick, I guess, for you. But I did try where I FOILed this through, and that worked. I know it takes a while, but I entered it in like this. So when you're done multiplying all this out, I know you got to put these in parentheses, these coefficients, and their fractions. But I did do that, and that worked. I'm not sure about the other way. I guess I'll check real quick for you. Yeah, I guess that'll save you some time. It will accept this answer right here just as it is. Just leave that out, and Webwork accepts it fine. I put that number outside in front in parentheses, and then put the rest of the parabola in parentheses. This next question is really tricky. It says that this polynomial has real coefficients and bounces off the x-axis at negative 18. So that one of the factors is x plus 18. If it bounces off the axis, it has to have an even root. We don't know what that even root is. It could be a 2, it could be a 4, it could be a 6, any even number. But let's say it's 2 because the first question says what's the smallest possible degree. The next point it bounces off is 95, so that factor would be x minus 95 squared, or to the 4th, or to the 6th, we don't know, some even root. And then x minus 1, same thing, some even root. And then it's got 2, it says that this is a 0, and so is this. That's what this is saying. It's saying if you plug in this complex number into the polynomial, you get a 0, and this one gives you a 0. So those are both zeros, which means that they have to be paired together with another conjugate. So those are basically 2 zeros in and of themselves. So there's 2 and 2, so that's 4, that's degree 4 just from these 2 zeros. And then there's, at least, so there's 4, 5, 6, 7, 8, 9, 10. So the smallest would be degree 10. Now it could be bigger than that, because like I said, it could, 32 is fine, because it could go up to, this could be degree 10 right there, really, an even number. So I would have to say yes to that one right there. It says find a degree 3 polynomial whose coefficient on the x cubed term is equal to 1. That'd be the A value, if it's a degree 3. The zeros of the polynomial are x minus 1, so that'd be x plus 1 as a factor. And then you'd also have x minus 3i and x plus 3i. So that these are zeros as well. And then just FOIL this out. So I would FOIL the first two. And then you get x squared. The middle terms are going to cancel, right? It's the difference of 2 squares again. Minus 9i squared. I squared is negative 1, so it's really x squared plus 9. And then I still have to FOIL that by x plus 1. So first times first, x cubed plus 9x plus x squared plus 9. Uh-oh. Sorry about that, I had some computer issues, but yeah, so you get this in standard form, that'd be x cubed plus x squared plus 9x plus 9. And they wanted to make sure that the coefficient on x cubed was 1, and it is, so that's my answer right there. All right, the last problem is a fourth degree polynomial. They want us to give all the zeros. And I'll be specific on a test if I want you to show your work and do this by hand. So you can do, keep in mind the rational zeros are at factors of the last coefficient divided by factors of the first. The first is 1, so I don't need to write that. That eliminates our possibilities, which is nice. So it'll be plus or minus 8, plus or minus 4, 2, and 1. Those are our possible rational zeros. Now if you graph it, you'll see that one of them is negative 1, one of them is 4. So it happens to be, the negative of 1 and positive 4. That on your work, So the factors are x plus 1 and x minus 4 so far. Now we know it's a fourth degree, so we know there's, either an irreducible quadratic of some sort right here, or two more linear factors right here. Not sure, but what we can do is do synthetic division. So I'm going to divide negative 1 into it, right, because that's the 0. You put the 0 here with synthetic division. I think this is the quickest, personally. And drop the 1 down, multiply, add, multiply, add, multiply, add, multiply. 0 remainder is a good thing. So what that means is this polynomial is x plus 1 times the cubic, which the cubic would be x cubed minus 4x 4x squared plus 2x minus 8. And I know that inside this cubic is x minus 4 though, right? So I'm going to divide x minus 4 into it. So I'm going to put 4 here now and divide it into this polynomial. Actually, I'll just do it right here. Drop the 1. Drop the 1, multiply by 4, add, you get 0, multiply by 4, you get 0, add, you get 2, multiply, and you get 8, so there's no remainder, which is good. So this thing actually factors into x plus 1, x minus 4, and then this quadratic, x squared plus 2, like that. So my solutions are negative 1, 4, and the two the two imaginary that come from this. So if you solve this by setting it equal to 0, and subtracting 2 from both sides and square rooting, you get the square root of 2i, and you got to do plus or minus. So positive and then negative I square root of 2. Right? I comes out as you take the square root of negative 1. So it's I square root of 2 and negative I square root of 2 for me, for my 4 solutions.